A very good morning to all of you. So today we'll try to understand the numericals on the dual converter. So basically, before starting with the numericals, first we'll try to understand the some concepts related with the dual converter. So as you know that when we say the numerical, so there are some values, and those values are the rated values. So when the rated values are given, the first step which we always follow is that to calculate the back EMF for the rated values. So that is E1 will be equal to VA minus IA into RA. So now we are more interested in doing the motoring and the braking operation. So for the motoring operation, VA will be equals to E2 plus IA into RA, and for the braking one, it is VA will be equals to E2 minus IA into RA. So when suppose if 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 both the converters are on three phase, then the equation will be V will be equal to 3 by pi Vm into cos alpha. If you are having a single phase, then the terminal voltage value will be equal to 2 Vm by pi into cos of alpha. Now you are having two converters. It means that the first converter will be operating as a rectifier, and the second converter will be acting as an inverter. So and these converters satisfy the relation, that is alpha A plus alpha B will be equals to 180 degrees. It means that the first converter, suppose the one converter will be operating at a firing angle less than 90 degree, and the other converter will be operating at a firing angle greater than 90 degrees. So in this way, by using this concept, we'll try to solve the numericals on the dual converter. There are three numericals which I have given. So basically, if you do the first one, then you will be able to solve the remaining two, because these are all similar, only the values are different now. So a 220 volt 1500 RPM. So basically, the two converters are used here. These are the rated values, and the armature resistance is given. The circulating current type of dual converter is given. So basically both the converters are operating simultaneously. In non-circulating current type of dual converter, the first converter will be operating, and then it is switched, and then that converter will be switched off, and then the pulses will be given to the second converter. So there is a dead band between the two converter, between the operation of the two converters. So now the converter firing angle you will have to calculate. So how to start with this equation? So first, we as a tradition we try to calculate the even value. So even value will be equals to what? Even value will be equals, that is the electrical equivalent. Even will be equals to VA minus IA into RA. So VA is 220 minus IA, that is 50 ampere is given, and this is the rated current is given. So basically this is 50 into 5, that is 20 5 so this is the 195 volt will be the answer. So this is the thing. And now the line voltage, the AC source line voltage, that is 165. So basically this is what this is your the RMS voltage is given. Line voltage means for RMS voltage is given, and so it means that you will have to calculate the peak value. Peak value will be equals to 165 into root 2, that is the RMS into root 2. So it is coming around to 33.34 to 33.34 volt. This is the thing. So now the will go for the first bit, the motoring operation at the rated motor torque. So you can see the torque has not changed, but the speed has changed. And for that, you will have to calculate the firing angle for both the converters. Okay. Now this is very simple. Again, we follow the same path. That is what we follow. That is N2 is 1000 RPM is given, and for this you will have to calculate the value of alpha A and alpha B, or you can say alpha 1 and alpha 2. So again E2 will be equals to what? N2 upon N1, because E is proportional to N. E is proportional to N, that is E1. So E1, that is 1000 upon this is 1500 into E1. E1 means 195. So if you just solve, then this is 130. Obviously the speed has reduced, so the back EMF should reduce by that proportion. Now, the next step is to calculate the VA2. VA2 will be equals to what E2 plus the motoring operation is there. Fine, the motoring operation, when you are talking about the motoring operation, the plus sign will come into a picture because the terminal voltage will be feeding the motor, and accordingly the torque is going to be produced on the shaft, and that is going to accelerate your, or you can say that is going to start your motor. So E2 plus I2 into RA, current is same because the rated torque is there. Then E2, it is 130 plus IA2, it is okay, that is 50. 50 into 0.5. So if you just solve this, I think 155 volt. 155 volt. So now VA2 will be equals to what is the thing value? VA to 3 VML upon pi into cos. This is line voltage was given. So we have already calculated the peak value. You just have to directly write this. That is VML. Okay, alpha cos alpha. VA2 is given 155. This is 3 into 233.34 upon pi into cos of alpha. If you just solve the value, I think we are taking for converter A because we are assuming that the converter A will be operating as a rectifier. So, but natural by default, the converter B will be operating as the inverter. So, I think it is 45.92. Now, how to calculate the alpha B? So, alpha A plus alpha B will be equals to 180 degrees. So, if you want to calculate the alpha B, so I'll just rub this. If you want to calculate the alpha B, so that will be what? Alpha A plus alpha B is equals to 180 degree. So alpha B will be equals to 180 minus alpha A. So 180 minus 45.92. 45.92, if you just solve it, so that will be 134.07. This is the thing which now for the braking operation. Now what to do for the braking operation? Everything will remain same. The only thing which you will have to change is this equation. Though everything will remain same, the only thing which you have to change, that is E minus RA into RA, because in this case the back EMF will be acting as a main source and back EMF will be providing the energy, and it will be giving back to the source. So I think this is a very simple one. You can just go through it. Just wait a minute. We'll go to that. Okay, where it is? Yeah, it is here only. I'll rub because it is not properly visible. Now it is visible. You can see everything is same. Everything is same. You can see this. For the braking operation, for the braking operation, you can see IA2, that is rated current, then N2 will be equal to 1000 RPM. So E2 will be equals to N2 upon N1 into E1. The same thing is given because the back EMF is directly proportional to the speed and it is electrical equivalent. So 130 volt. You can see for motoring operation, we have got the same value, and the same value is achieved for the braking operation. Now, the next step is for motoring. It is plus. Obviously, this is applying the voltage, and the in the braking operation, the power which is stored in the wheels will be giving back the energy to the source. So obviously, E2, some part of E2 will go to IA2 into R, that is the armature resistance drop, and some part will be going towards the supply. So this is VA2 now. So cos alpha, just calculate, because we have also the three-phase supply. And I think in the class also I told you about the three-phase converter, because generally dual converter, because if you are using two converters, no, then these two converters should be used for high power rating. And why we are using this dual converter? Because basically in dual converter you can achieve the four quadrant operation, which was not possible with the single phase, half wave and the full wave. So this is cos alpha will be equal to Va2 into Vm. So this way, like the thing which we did for motoring, the same thing which we have is to be done for the braking one, alpha A plus alpha B. Now the speed is minus 1000 RPM. Again, the control rectifiers will interchange. Obviously, the converter B will be acting as a rectifier in this case now. Fine. This is for the minus 1000 RPM because the converter A, the converter B will be acting as a rectifier and it will be driving that DC motor in the third quadrant, that is a reverse motoring quadrant. So I think just refer this. So the rest will be simple only. So in this way, we have completed the numericals of the DC drives.